Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve the systems of inequalities by graphing. And so what we're going to do is we're going to graph each inequality separately. Now, usually what I like to do is convert these over to equations and use the shading. But basically in this case, we have these both in slope-intercept form. And hopefully if you can just, recognize here that the y-intercept in this equation is -1, and the y-intercept in this equation is 3, as well as the slope in this one. I thought I was going to use the red. The slope in this one is going to be 1, but we always want to write the slope as a fraction, so we'll write this as 1 over 1. And this one we'll write as -1 over 1. All right? And the negative sign can be in the numerator or the denominator. Either one, it doesn't really matter, as long as you don't put it in both, -1 over -1, because then that would be a positive one, and this slope has to be negative. So to graph this, I'm going to kind of forget about the shading for a second and just kind of pretend these are equations. However, I do notice that both of my inequality symbols are less than and greater than, not less than or equal to or greater than or equal to. So therefore, I am not going to be graphing solid lines. I'm going to be graphing dashed lines because both of these boundary lines are not a part of the solution. So I have my y-axis and my x-axis. The first thing I want to do is plot the y-intercept for each equation. Well, I'm sorry. For one equation, let's graph one equation at a time. So the first one, the y-intercept here is -1. So I go down on the y-axis to -1, and I make a nice big dot. All right? That's my y-intercept. Then I follow the slope, which is 1 over 1. That means the change in the y-coordinates is +1, and the change in the x-coordinates is +1. So I'm going to go up 1, over 1. I could also say that's a -1 over -1, which would still produce a positive 1. So I could go down 1 to the left 1. But either way you look at it, you can see they're going to be on the same line. And remember, they're going to be dashed because it's not a part of the solution. And there's my graph. I'm going to do the shading at the end once I've graphed both equations. Now, to go on this one has a y-intercept of +3. So I go up to 3, 1, 2, 3, make a nice big dot. But now my slope is -1 over 1. Well, -1 over 1 is the same thing as 1 over -1. All right? So it doesn't matter which one I want to do. Just like the positives, I could go up and over. I could go down and to the left. Here, I could go from here. I can go down and to the right, or I could go up and to the left. But again, still, you're going to see we're going to have a dashed line. Now, the last step we need to do is determine our shading. Are we going to be shading above or below each boundary line? So to do that, we want to pick a test point that does not lie in either of the lines. And the best test point to pick when it doesn't lie in the lines is 0, 0. So now, I'm just going to plug in 0 in for x and for y for both of my inequalities and determine if it's true or false. So my first inequality that I graphed right here, I plugged in 0 in for y and 0 in for x. And I get 0 is less than -1. Now that is false. So for this inequality, since my test point is false, that means all the points above the boundary line are false, and that means all the points below are true. And I'm just going to draw arrows here until I get to actually graphing, or until I test both of my boundary lines. Then I'll go ahead and plug my test point in for this equation. So 0 is greater than -0 plus 3. Well, there is no such thing as -0. 0 is not positive or negative. So therefore, So therefore, I have 0 is greater than 3. Well, 0 is not greater than 3. That is also false. So therefore, for this inequality, my test point is false. That means all the points below this boundary line are false, and all the points above are true. Then I'm just going to shade where it's true for both of my inequalities, which would be that region right there. So there you go, ladies and gentlemen. That is how you graph a system of linear inequalities. Thanks.